In March, I finished a hot air coffee roaster after finding an OreckXL vacuum cleaner for $4 at Goodwill. I've roasted 85 batches with it in the last 8 months. Since it seems to be working well, I made a video to illustrate some alternatives that might be of interest if you decide to try your own design. The motor blows air through a Prest PopLite popper heating assembly modified for 1.8 kilowatts. To boost the heating even more, some of the hot exhaust is sucked down into the base where it mixes with a variable amount of ambient air before being pulled back up into the blower. Air temperature going to the motor is monitored with a separate pyrometer and can get up to 150 Fahrenheit. Roast chamber temperature is measured with a MAX 6675 and K thermocouple, with a nano sending that to Excel on the serial interface. An LCR displays heater volts and amps, and an LED display alternates between blower watts and motor outlet temperature in degrees Fahrenheit. Data is imported at 3-second intervals to Excel, which plots roast profile against the target. Process adjustments are made with an ambient air inlet and blower speed. Here is the typical bean motion near the end of the roast. When heating is finally cut and ambient air opened up, the batch cools very quickly, quenching the roasting process. After a few minutes of cooling, the blower is shut off and the recirc inlet and chaff collector are removed. Then the blower is turned back on momentarily to blow out any remaining chaff before discharge. After the draw clamps are loosened, the roast chamber and globe assembly is lifted off and the batch is poured out. Then the next 340 grams of greens is loaded. After resetting the data collection software, the blower is powered on, then the heater is set. The chaff collector is emptied every 2 to 3 batches. I replaced the resettable OEM thermal fuse on the motor with a higher value, but the controller also monitors the motor outlet and is programmed to shut down at 205 Fahrenheit. Normal range is 160 to 190 Fahrenheit. I replaced the 30 gauge inner heating coil with a 26 gauge to lower parallel resistance and increase power output. The control box provides useful data and also will shut down heater power if the blower slows or stops, or if the motor outlet gets too hot. The roast chamber is a 3-cup stainless steel bowl fitted with a homemade perf plate and part of an aluminum funnel with 60-degree sides. The rings and tubes are high-temperature silicone elastomer. The thermocouple is insulated from the chamber walls with the tip located off-center. The pyrometer reads air inlet temperature to the motor, while the MAX 6675, wrapped in black tape, is reading the roast chamber thermocouple and goes to the nano, which sends time temperature data to Excel every 3 seconds for display. The fused 20 amp auto transformer is connected to a 20 amp 120 volt AC line in our kitchen, which is not on a GFI. I use the auto transformer to keep line voltage to the system constant in the vicinity of 120 volts AC. There's a 100 mesh stainless screen over the ambient air intake and also a 5-inch diameter mesh disc between the air mixing box and the motor. The disc is switched out for a clean one every 5 or 6 batches. The motor PWM control is in the front and the heater PWM in the back rear. Roast profile is controlled with motor speed and ambient air ratio. The heater power is at max for all but the first minute. Thanks to the many members of HomeRoasters.org for helping me get started with popcorn popper mods about 3 years ago, and with the great support and encouragement all the way through this most recent project.